I just realized that I started recording, but I didn't remove my previous VOD. And I don't have that much space on my hard drive, so it's actually kind of dangerous. So I think the previous VOD is this one. It's around 3 gigs, so I might as well actually remove it. I don't have to remove it recursively, but I have to remove it nonetheless. So if I grab MKV, so here it is, and this thing is growing. That means the recording is going. Yes, yes. The recording is going. The VOD is growing. So hello everyone to yet another offline stream when I'm on vacation, and today is Thursday 13th. How about that? Almost unlucky day, and that means today, according to the schedule, we are developing our Twitch bot. These offline streams become more and more pathetic every fucking time. So yeah, we're not streaming on Twitch, but we're developing a Twitch bot. Because when I come back, this shit is better be ready, okay? So this shit is better be working there, banning all of the backseaters and stuff like that. So, but yeah, maybe we're not gonna work on the chatbot directly. So let me see what we can do in here. So maybe I'm gonna just work on the technological part of the chatbot, not on the features, right? So because we have a little bit of a difficulty to developing this thing, because we're trying to develop it from scratch in C. Who would have thought, right? Who would have thought that implementing things from scratch in C is difficult, right? Surprise Pikachu face, but that's precisely why we're doing. So it's called KGBotka, and you can find the source code of that thing at github.com/tsoding/kgbotka2. I think. Let me go on there, and it's gonna be in the description. So this is the source code of this entire thing. So it's like a 50th iteration of the bot. I keep rewriting the bot, and yeah, it is what it is. Nothing much to say. So let me test that bot, I suppose. Let me test that bot. So do I have to go to the source code? I think I have to go to the source code. It's going to be KGBotka2, and let me see. So we have some branches. I wonder if I actually merged those branches. I don't quite remember. So merge origin master. Okay, so I think I merged all of that, and let me see if I can easily recompile this entire step. Everything seems to be working, everything seems to be recompiling. And let me try to run it. So if I run it, it asks for a secret file with the configuration and stuff. So I can try to provide the secret file. And one of the important things it does, it initializes curl, SSL, and also tries to connect to Discord and Twitch and stuff like that. So it managed to connect to Discord successfully, more or less, even authenticate. But it struggles to connect to Twitch. Oh, I see. Because recently my main bot token has expired. Yes, and I actually updated the token on all of my production bots, but I forgot to update it in the configuration of like my development configuration. So this is something that we'll probably have to do now. So since I'm not editing these VODs, I'm gonna be doing it live, but not live, but offline. So let me quickly do that. So let me actually bring in the face, and here's my sign, trying not to leak any sensitive information. So if I leak something very, very badly, maybe then I may consider editing things, but not right now. So I'm too lazy to edit things. I'm sorry. Okay, so I'm gonna just grab the token from one of my production instances. I think that's gonna be the way to go. I need to resist the urge to comment everything I do, because when I'm streaming, I comment in everything I do, and when I'm dealing with the sensitive information, I have to remind myself, Zozin, you don't have to comment everything you're doing. As a matter of fact, you should not do that. Just shut up, don't say anything. But it's kind of hard when you get used to like commenting everything you're doing, right? It's just kind of hard. Okay. I think I managed to copy the tokens. And I'm almost ready to show you my screen. That's right. And if I try to run it, the bot is successfully connected, and I can even ping that bot. And you can see it being in the chat, and I can look for the weather. So what's the weather in Novosibirsk? It's +18. Okay, nice. So it's a mature weather. Oh, mature is supposed to be 18 plus, not plus. Okay, whatever. It's not a funny joke anyway. So, all right. So that's basically what we have in here. We have a simple boat written in C. Oh shit. Fuck. Yeah. Say hi to YouTube. All right. So. I'm actually offline, believe it or not. It's just like I have my layout like configured, and I'm too lazy to change it, and I'm actually afraid to change my layout and my setup, because if something something breaks, I just don't want to deal with that. So I'm sorry. So it's just like the same layout. I'm recording and streaming with the same layout. Okay, so and the entire thing actually depends on a few things, only on a few. One of them is OpenSSL. Sorry. Yeah, I know there's a lot of opinion about OpenSSL, but it is what it is, and it isn't what it isn't. And another one is libcurl for HTTP requests. Right, it's libcurl for HTTP requests. So the main thing I'm unhappy with is libcurl. Because it's more complicated. Like using this library is more complicated than we actually need. It's kind of difficult to explain. So libcurl is a very old and widely used library. Right, that's what it is. Everybody knows about like this library, and also everybody knows about like this utility, command line utility that lets you query things from the internet. Right. So, and because of how big, old, and complex it is, and because it has to work in so many environments, it's actually very, very complicated, and it does a lot of things that we don't need. And because it's trying to do this a lot of things, it imposes the interface that we have to integrate with. And as a matter of fact, it has a very unintegratable interface. So basically, it expects you to build your application around libcurl, if that makes any sense, right? And it kind of makes sense because it's supposed to facilitate, it's supposed to power the curl utility. So it's basically curl utility, but in the form of library. So of course you're supposed to build your application around libcurl because that's what it's designed to be. It's not really even designed to be a library, right? It's more of like a framework or something that you like, and you have to build everything around that framework. And to be fair, we have a very simple, bot. We have a very simple bot. And it doesn't need all of that. And using libcurl in our bot feels like using like a, tank tracks on a bicycle, right? We have a small bicycle and we're trying to attach like a tank tracks. So that's what it feels like. And I was thinking like, can we maybe implement our own replacement for curl? I know, you're not supposed to write your own HTTP library, you're not supposed to write your own TLS library, you're not supposed to write your own browser, you're not supposed to write your own operating system, you should just cry and curl in a corner. I know all of these things, but, we have a very simple use case. Can we just implement like a very specialized library for that specific? I know that you're not supposed to do this kind of thing, but I mean, it's an experimental project, okay? It's an experimental project. And we're just experimenting, we're just having fun, and we're not, you know, it's not for production, it's not for everything. Like, there's place for libcurl, of course, I do understand that it's used like in enterprise and stuff like that and everything. But maybe, just maybe, we could at least try to do that. So yeah, and actually, speaking of how exactly we're going to implement that library, yes. Oh, by the way, another thought. I think like implementing a replacement for this specific project for libcurl is almost like implementing your custom game engine, right? You know what I'm talking about? So quite often, like I also write games. Like, well, I mean, I'm trying to. I'm not a game developer, but I'm trying to write games, and I also write the engine for them from scratch, and it's so solely based on the on OpenGL. All right, and yeah, so this is how they look like. So you can, it has a lot of different triangles, so it's more of a technological demo rather than an actual game, but all of that is a custom engine based on OpenGL. And people quite often ask me, why do I build this stuff from scratch, which is not necessarily from scratch, I'm using OpenGL, from scratch would be even more complicated, and not use one of the well-established engines and you know, Unity or Unreal Engine, right? So why would you go through the effort of implementing your own engine and not use a ready engine, you know? So, and this is because quite often when people say engine, what they mean is Unity and Unreal Engine. And Unity and Unreal Engine are very, very complicated and big pieces of software. And when I say that I'm implementing my own engine, in their head, it means I'm implementing my own Unity and my own Unreal Engine, which is not the case. No, I'm not doing that. I'm not crazy. Well, maybe a little bit, but not that much, right? I'm not implementing my own Unity. I'm not implementing my own Unreal Engine. I'm implementing a small enough engine in which I can implement that specific game. Look. This game doesn't look visually impressive. How complex an engine for that game should look like? So to actually make such a game, you don't need the complexity of Unreal Engine and Unity. Actually not. It's actually super simple. It's way simpler than Unreal or Unity. So essentially what I'm doing is just implementing enough functionality for my specific game to work. And I think similar thing could be applied to our bot, right? So when I'm saying that I want to replace libcurl, I don't want to rewrite the whole libcurl from scratch. No, this is not what I'm saying, right? What I'm saying is that I want to implement like enough functionality that it solves my problem. So, and another question that could be asked on why I'm doing that is, what about security? It's unsecure, unsafe language, right? And stuff like that. So, and you probably will have buffer overflows and shit like that. Well, I'm not deploying this bot to production yet. Right. So when I'm about to deploy this bot to production, I will actually try to test it and maybe fuzz it and just see if there's any like sort of buffer overflows or vulnerabilities, or maybe statically analyze it, or maybe even dynamically or something like that. So I will try to see if it can be broken in any way before actually using in production. And again, this whole purpose of this entire thing is to actually learn something, right? So, and once we have a vulnerable application in C, we can use it as a playground of learning how to hack things, how to binary explode things. You see what Twitch chat does to me? You see, this is precisely the reason why I'm not streaming anymore, because I feel the need to explain these things over and over again, because there's always some annoying people who will ask all these questions over and over again. And yeah, there you go. Here's Twitch PTSD for you. Anyway, so, and I spent like 15 minutes on this kind of shit. It's just like, people just cannot comprehend that sometimes you code for fun and you're trying to learn things. Just people cannot comprehend that. I swear to God, streaming is gonna be a death of me. Seriously. Anyways. Fuck. Well, I finally broke it. I finally broke it. So yeah, at least I caught that on camera. So it's actually it actually cracked. It actually cracked. So I have no vessel for making tea. Press F in chat for the French press. It didn't survive even for a single year. Anyway, I'll have to throw it away now. Just a second. Do I even have any? I don't have anything, so I'll probably have to rely on the tea bags. All right, so let's go and bring the tea bags to the party. It is what it is, and it isn't what it isn't. So, recently I was actually deep into immediate mode APIs things, if that makes any sense. One of the previous streams was about immediate UI. Right, so, and I was actually implementing immediate UI library. So maybe I'm gonna actually leave the link to that stream that I'm talking about in the description, so you can watch it if you want to. So where is the Zozin VOD channel? Zozin VODs. Zozin VODs channel. Yeah, so it's this one. Yeah. So I'm gonna put it in the description so you can watch it. So this is basically what I'm referring to. So immediate, maybe let's call it a recent immediate UI stream. Right, so I was working on that. And before that, I was also working on immediate JSON serialization library. This is a very interesting concept. So essentially, the immediate versus retained API can be applied not only to UIs and graphics. Apparently, it can be applied to a lot of different things. For example, JSON serialization. JSON serialization can be also immediate and retained. In case of a retained JSON serialization, you prepare the JSON AST, then you give that AST to the library and it serializes it into like text or whatnot. So in that case, it would be a retained one because you prepare your AST and then you just call one function and it just like serializes everything. It could be also done in immediate fashion, right? So for example, you can do something like this. You begin an object, a JSON object, and here you end the JSON object. And between these object brackets, you can put things like, okay, so member with the key null is going to be null. Member with the key boolean is going to be actually array of 2 elements, right? And a member with the key integer is going to be actually, how many of them? 7 integers, like 3 negatives, 3 positive, and 1 0. I think it's going to be 7 integers, right? And so on and so forth. And basically, then it will print this thing. Of course, it's pre-printed with JQ, but besides the point. So, and basically every time we call one of these functions, we actually give the pointer to the context, to the state of the library, and the state of the library is used to keep track these commas. And you know what's cool is that these functions immediately print the text to the output. So the text is not printed when you run one function and then this function iterates the AST, like traverses AST and then prints everything. No. The text is actually generated on each call of this function. Each function contributes a little piece of serialization, right? So, and what do I need to say? Yes, it contributes. That's why it's called immediate, right? So it immediately prints everything. And one of the advantages, I suppose, is the same as the immediate UI advantages. There's no duplication in terms of like data. So usually in case of JSON, you're going to have your own data, and then you'll have to convert the data into the JSON tree and then serialize the JSON tree. In case of immediate, you don't even have to convert any trees. So you have your data structure, you can just traverse your data structure and generate the JSON from it without like duplicating data or anything like that. So yeah, I'm gonna give the link to this entire thing in here. So it's kind of similar to immediate UI, but it's for serializing JSON. JSON serialization library. So I can actually try this library on the stream just to demonstrate what I'm talking about, because I think it's kind of cool if you like see interactively what it actually does. But before I can do that, I think I need to make a cup of tea. I think I need to make a cup of tea. So since I actually broke my French press, and I do make tea in a French press, I'm sorry, I'm Russian. All right, so it's, I can do whatever you want. So yeah, we're gonna be using tea bags. We're gonna be using tea bags. I don't like tea bags, to be fair. Not sure if it's a placebo, but every time I drink tea from a tea bag, I can taste the paper for some reason. Like, I don't know why. Maybe it's my brain tricks me into thinking that it tastes like paper because I see, okay, there's a paper in there. Maybe I won't be able to taste it in a blind test, but that doesn't change the fact that I still taste the paper. So even if I'm delusional, right, that does not magically make the illusion disappear. So so I'm gonna go to the kitchen and put up some water, warm up some water, and I'm gonna be back and I'm gonna show you what I mean by immediate JSON serialization. Immediate JSON serialization. Okay, good. All right. So I'm gonna go somewhere, maybe something like prob. And do we have? I think I cut myself on the glass from the French press. A little bit, just a little bit. Anyway, so let's put something like gym in here. So here's the folder. So the library is header only, right, and in STB style. So that means you can just grab the header, right? You can just grab the header, download it, and put it into your project. You don't have to do anything special. You don't have to build it. You just copy paste the header into your project. Then you include the header. And there you go, the library is in your project, but it doesn't contain any implementations. The header by default acts like a header without any implementations of your functions. So what you have to do, you have to define gym implementation, and now it will act as both header and a C file. That's the point of this macro, is that you control to which translation points implementations of these signatures will go. Right. So since we're going to have a single translation unit, we are going to put everything in there. We're going to put everything into the main. Right. So let's now add the entry point. And first thing you need to do, you need to construct a context, right? And the context accepts two important things, the sync, right? So where you're going to be outputting everything. So we're going to use std_out, and the write function. The write function expects a signature that is similar to fwrite. So that means fwrite is compatible here. By constructing this sort of context, you're able now to just print the serialized JSON to the standard output, right? And by the way, my tea is ready, so I'm going to go to the kitchen, pour myself a cup of water, and I'm going to be back, and we're going to continue working on this thing, and I'm going to continue demonstrating this library. I finally got tea. So, for instance, you want to create an object, right? You do gym object begin, and this thing begins an object. And then you say, I'm done with the object. I'm going to put end in here, and that's it. That is going to generate you an object. So if we try to build this entire thing, right, it doesn't even compile, because yeah, we have to, I think, cast this entire thing to gym right, because the signatures are not particularly compatible. And what does it say? It doesn't really like. Is that because I never included stdio and stdlib? This is why it cannot compile. Yes, of course. Thank you, GCC. Very cool. What a nice compiler. Always gives me relevant information. All right. So, and if I try to run this entire thing afterwards, we got an empty object. So to demonstrate that it actually prints on every of the functions, I'm going to actually not end the object, and you're only going to have this thing in here. All right, so let's say that we're going to have some members, right? So it's going to be member key, and it's going to be gym. And what kind of keys do we want to have in here? So we're going to be having foo, and under that foo, we're going to have a gym integer, right? Let's actually put some sort of integer in there, and that integer is going to be 69. There we go. If I now try to run this entire thing, as you can see, we got an object with the key foo and the value 69, right? So we can also quite easily wrap that into an array. Gym array begin. So this is where array starts, and this is where array ends. Right, so here is an array, and we can even do that in the loop, right? So what if we actually generate like 10 elements right, in that specific array. What's gonna happen? Let's see. So I'm gonna put I in here, right? It's gonna be I, and there we go. We have 10 elements in here, and look at how it keeps track of the commas. Right, it puts commas in correct places. There is no trailing commas or anything like that. It tries to generate absolutely correct JSON according to the specification. Right, so after that, maybe we can have another member, gym member key gym bar, and that thing is going to be gym string. I think it's going to be just string. Something like hello, and so on and so forth. As you can see, you can just keep building your JSON. And what's interesting is that if you have some sort of like a tree-like structure, to generate a JSON out of that structure, you can just traverse your structure and generate as you go, as you traverse it, without converting it to a different kind of tree. So there's no like data duplication. So you already have a tree. You can just traverse it and just serialize it to JSON without creating another separate tree, right? So this is basically immediate JSON idea, right? So, and this idea was inspired, as I already mentioned, by Immediate UI. Immediate UI also does things in a similar way, because UI is also about traversing trees, if you think about it, right? So your user interface is like a nested structure, so it's sort of like a tree, and you can basically handle that tree in immediate mode and or retained mode, similarly to the JSON here. I think there are similarities in these particular cases. What do you guys think? Leave a comment down below. All right, so, and what I was thinking is that, can we apply the same to HTTP? Can we apply the same to HTTP? So I think, even though in HTTP you don't really have a tree, but I don't think it's actually quite necessarily important to trees. But I think it's sort of applicable as well. So how an immediate mode HTTP library would look like. Right, so let me actually see. So you have an entry point, right? You have an entry point. I cannot even create an entry point, right? So, and you do something like HTTP begin, right? First of all, you have some sort of a HTTP context, right? HTTP context, and you do HTTP begin, right? And then you do an end. And when you do a begin, it automatically opens a connection, right? Automatically opens a connection. And then you start preparing a request, right? So something like HTTP request begin. You start a request. And as far as I know, maybe you have to, yeah, you need to specify now the path and the method, right? So you would provide something like HTTP get and something like slash, and maybe here you'll have to provide the host, right? So there's no parsing of URI in here. It's just like a purely how would you do HTTP, right? So you start this thing, and then you start adding headers, right? So you would do something like request header HTTP, and so I think request header should also support printf format arguments. Basically, if you have something like authentication, you should be able to do something like authorize or whatever, right? And you can put your token in there. It doesn't matter. The specific names don't matter, but so I want to be able to do these kind of things. And then you can add more different headers, like full bar, and then you can say HTTP request start body, right? And this is where your body starts, and you maybe send some body chunk, somebody chunk, and it could be a text or could be a side string, and then you say HTTP request end. So this is where you ended your request. Right, so you can put something like this. And since it should be an immediate mode library, it will send out the status line, the headers, and the body immediately as you call this function. So basically, it sends them immediately and doesn't retain them. So yeah, a lot of HTTP libraries, they're sort of in retained mode because first you prepare your request, you prepare the structure, you decide on the path, on the resource, on the method, on the headers, on the body, and then you prepare everything and you then give it to the library and ask the library, send that request and give me the response. And then the library just collects the entire response, parses everything, verifies everything, and then only then gives you the structure where that response is located, and then you make decisions based on this kind of information. So what I was thinking, like, can we just do that in immediate fashion so the user has control of each and individual element? That makes the library not particularly like beginner friendly, like people who don't really know how HTTP works under the hood probably won't be able to use it, but that's not our requirement, right? So we just want to have like a simple replacement for curl in our bot, right? And bot is developed only by me, so it doesn't really have to be beginner friendly. There's no such requirement, but maybe, like, I don't know. And it sounds bad. It sounds bad, but I mean, yeah, what I'm trying to say is that yes, it's not beginner friendly, but it's not the biggest problem. So let's just keep experimenting, right? The library is not implemented yet, okay? You see, I'm arguing with invisible chat because, like, I know what people is gonna say. What a miserable person I am. Anyway. So yeah, so this is immediate request, and then how we handle responses in immediate fashion as well, right? So it's going to be HTTP response begin, and maybe here we will step away from the immediateness of the library, and we're gonna collect ahead the response and the headers. So we can actually put the response and the headers into the HTTP structure. Yeah, this is one of the things we can do. So HTTP response end, right, something like this. And then we can check if HTTP status, right, is equal to 200, then we just do something, like we can take a look at the headers, right? So I don't know how we're gonna look up the headers, but maybe we can iterate the headers. So maybe it's gonna be array, which we can iterate for I, and so on and so forth. And then I guess in immediate way you would be able to also receive the chunks, right? So you will be also able to receive the chunks of the response if it's chunked in coding or something like that. But here's an interesting thing: how would you handle redirects? This is what's interesting about it. How do you handle redirects? So, well, I think you can do something nasty, but interesting at the same time, right? You can do something nasty and interesting by the same time. You can use Go too. So if the status is something like 300, right? And let's imagine that we have something like a URL, right? So you have an initial URL somewhere here, https://tsoding.org, right? And then you provide this URL in here, right? And then maybe you don't have to provide this thing in here because it's going to be stored inside of HTTP, and the only thing we'll have to provide is HTTP GET, right? Something like that, right? So if you get something like this, what you do URL equal HTTP, like new location, right? New location. Then you end the response and you try again, and again goes here. And again goes here, something like that. This is like a rough idea. Or maybe you can even try again somewhere here. If HTTP, yeah, maybe if you move URL somewhere here. This one is actually pretty complicated, but yeah. So the idea is that maybe you will also be able to maintain a connection with a keep alive or something, right? If you redirect it, right? If you redirect it, you can try to go again while maintaining the connection established by HTTP begin. But how the HTTP begin knows where to connect if this is where we provide information about host and stuff like that? It's kind of, it's kind of complicated, but not necessarily though. Not necessarily. So maybe you close the connection. Maybe you close the connection in HTTP end, and the HTTP response end doesn't close the connection yet. It basically signals that response is over and you start a new one. Right. So that's actually pretty cool. So yeah, if you start this thing in here, it may establish a connection, but it doesn't close the connection until there's HTTP end or something like that. So it would be very interesting to explore this idea. It will be very interesting to explore this idea. So yeah, again, I'm not sure if this is generally a good idea, right? Yet again, I feel the need to say a disclaimer. I'm not sure if it's a good idea. I'm not saying that everybody has to use and everybody has to program in this specific fashion. I'm not saying any of these things. I'm not saying that curl is bad. Curl has its place in certain applications. It's just like it doesn't fit my goals. It doesn't fit my goals. So, and again, I don't know if this is a good idea, and this is precisely why I'm implementing all of that, right? I can clearly see that this may trigger some people, right? Implementing HTTP in this way definitely will trigger some people for no reason, for no good reason. But again, I'm experimenting. I'm trying to see whether it's a good idea generally. And it's difficult to give a definitive answer whether it's a good idea unless we have it implemented. So this is, I'm using a non-existing API in here, right? So I'm using a non-existing API. This API doesn't exist. I just pull it out of my ass, right? I'm really sorry for being like that. It's just like years of Twitch just put a huge dent on my soul. Yeah. Anyway. So, what's going to be the plan? What's going to be the plan? The plan is going to be to implement a rough idea, like roughly implement it. I don't know much about HTTP. I don't know the specific details and specific pitfalls of HTTP yet. I roughly understand how HTTP works. So essentially, you open a connection to the host, you send the method and resource that you want to get, you send headers, then you set empty line, then you send a body, and the server responds with the response, which is status line, the response headers, and the response body. Essentially, there's also different complications like HTTPS, keep alive, chunked encoding, gzipped encoding. I'm aware of those things, but maybe there is more. There is more. So, and we don't know all of the pitfalls yet, and that's precisely why we're implementing it, just to discover all of them, right? How can you know that there is like a hole in the ground if you never actually went there and and looked that there's there is a hole there? Right, well, you don't necessarily have to fall into that, but you see what I mean, right? So I'm gonna implement the library from the point of view of my knowledge about HTTP, which is really limited. I do realize that. You don't have to tell me. It's very limited. And then once we have a rough implementation that works for simple cases and we can query simple websites and simple APIs, I will look into RFC for HTTP 1.1 and try to go through it and see what kind of other pitfalls we may have and try to maybe implement HTTP 1.1. It's not going to be fast, it's not going to be easy, but I want to get at some point at least HTTP 1.1. I know, I'm aware about HTTP 2 and how complicated it is, multiplexing, stuff like that. I'm aware, I know all of that. I'm experimenting. I know it's hard. That's precisely why I'm doing it. There's no reason to start crying and curl in the corner and not doing anything. Okay? I really apologize for my behavior. It's just like, yeah. It's just the arguments, the things that I'm arguing with, the imaginary things I'm arguing with is the things that I kept hearing like over the years while streaming on Twitch, and it's just like, yeah, really getting to me. Anyways. Paper. Taste of paper. All right. How are we gonna do all of that? So, how should we call our library? How should we call our library? So if immediate GUI is I'm GUI, maybe the library has to be called I'm HTTP. I don't really feel super creative today, or maybe it's just like kind of difficult to come up with an interesting and creative name for immediate mode HTTP. So yeah, I guess I'm gonna just call it I'm HTTP. Right, so it's gonna be I'm HTTP. Right. So and let's just go ahead and do that. I should have actually wrote a README. I'm HTTP immediate mode HTTP library. Right, it's immediate mode HTTP library. I'm not gonna put too much description about it here yet, so I'm gonna give it a license. Right, so here's license, gonna be licensed under MIT. That means you can do whatever you want, even sell it if you want, but you won't be able to sell it because it's shit. Right, so and let's make it an STB style header library. I kind of like STB style header libraries because like how simple and small they are and how easy to integrate them and how difficult it is to patch them in production because they're not dynamic libraries. You know, all the good things. All right, so let's put the inclusion guards. I'm http.h define and if and obviously we're going to have some sort of a context, right? And that context is going to be I'm HTTP. Right now we're not having anything in there, right? We're not having anything in there. And I don't even know how we're gonna decouple all of that from a specific specific like socket implementations and whatnot, right? Because in different operating systems there are different socket interfaces. I mean, like WinSocket is pretty much Berkeley sockets. It's just that you have to do additional calls to initialize it and so on and so forth. And also there's OpenSSL if you want to do HTTPS, but maybe we're not going to do HTTPS today. Maybe I'm gonna abstract it out the same way Gym is abstracted, the JSON immediate library, right? In the JSON immediate library, so essentially you provide a sync and a write function, right? It's a sync, and I think I need to actually put some sort of a padding as I usually do on my streams because it kind of like the chat covers everything and it's just like, okay, I'm gonna put this thing in here. All right, cool. So now at least you can see everything. Hopefully that is better, but it makes it look like I have a chat, but I don't really have a chat. So I don't know, I'm gonna put something in the chat. Yeah, there we go. So essentially in a Gym I have a sync and a function that writes into the sync. So maybe I'm gonna have a similar thing for the HTTP library. So you're gonna have a sync, which is like some opaque pointer and a bunch of functions that can write and read from that sync, right? And then it's up to you to provide implementation for these things. These could be Linux sockets, this could be Win sockets, these could be OpenSSL sockets and whatnot. And it's just like, it's up to you to like provide them. So you just try to adapt them to this specific interface. And maybe with the library, we're also gonna ship like standard some predefined implementations for plain sockets, for OpenSSL or something like that. It's just like, yeah. But let's keep things simple for now. Let's keep things simple. So, so maybe we're gonna have something like type def. So, and socket is an integer, right? A socket is an integer. What we're gonna do? What if we define this I'm HTTP socket as a pointer, right? Right, it's gonna be a pointer. And if you wanna implement the plain sockets, which usually have like just a regular handler, which is an integer, you can store that integer within the void, right? Within the void, because it's a pointer, and I think integer can fit into the pointer. And if your socket is not just a single integer, you can just store it somewhere in dynamic memory or a static memory, and just give the library the pointer, right? I think making this thing just a void star is a reasonable abstraction, more or less a reasonable abstraction. Okay. So another thing we'll need HTTP write and read functions, right? Unlike in Gym, we not only have to write things, we also have to read them, especially when we're doing response. We're looking at the response, which is kind of interesting actually. What if for the request context and for the response context we had separate data structures? Something like, I don't know. CPC mode. So maybe a request. So it's 0 initialized. Maybe it should be called actually rec. Then rec begin and rec end. But then it's unclear. Nah. Yeah, let's not do that. I think having like a single structure for everything should be alright. I think having a single structure for everything should be alright. Right, so we're gonna have a read and write, and then I'm gonna have a type def, which is HTTP write. Right, it's gonna be a pointer. And the question is, what's gonna be the signature of that thing? So I think I'm gonna use the signature of write syscall. I think it's reasonable enough, so it returns as size, right, as size t, and then it accepts the HTTP socket, right? Then it accepts buffer, and then it accepts count. But if the socket is an integer, I think integer is smaller than the pointer on 64-bit architectures, so you won't be able to actually assign write directly. I suppose you'll have to write a wrapper around write, at least for now. Yeah, you'll have to write a wrapper around, I think. Okay, that's totally fine. So then we're gonna have something like a read, and let's take a look at a read syscall, and this thing is also accepting socket, but the main difference is that buffer is modifiable because we read into the buffer. Right, we read into the buffer. All right, so here's a socket, here's a write, here's a read, and do we need anything else? I'm not sure. By the way, the fact that you have to provide this thing outside of IMHTTP, that means the connection is established not by IMHTTP. So when you also need a separate library that can parse your URL, right? You can parse your URL and extract the host, extract the resource and stuff like that. And what we're gonna do about that? So I suppose maybe it's gonna be outside of the scope of this library for now, right? Because we're trying to implement something working. So the only thing we're gonna accept is the socket that already established connection, right? So we're gonna assume that it already established connection. And the resource that you're querying is going to be provided via something like IMHTTP begin, right? So IMHTTP begin, right? Of course, like it's not probably sufficient enough. It doesn't fit use cases, but this library is unfinished. Okay. Keep forgetting that there is no chat. Okay. So what do we have in here? So we begin, and maybe here we have to provide something like I'm HTTP method, right? So this is going to be the method. And also we have to provide the resource, right? So the resource that we're querying in here. So I'm HTTP end is going to end everything. Okay. So we also need to specify what is IMHTTP method. Let me remove this entire thing. It's going to be type dev enumeration. So it's going to be method, and I'm HTTP get. For now, we're going to have get post, and that's going to be it for now. So when we need more things, we're going to implement them later. Of course, it's just not that difficult to add them later in here. So I'm just trying to implement a like very small, very minimal thing. That's what I'm trying to do. So I do HTTP begin. I forgot how HTTP actually works. HTTP request example, and I'm pretty sure I won't find anything here. Oh wait. I had a gist where I made like a very simple HTTP request. Wait a second. Yeah. Oh shit. I need to do. I think I can find it here. Oh fuck, my boat is down. Let me quickly restart my boat. The boat. Just a second. Oh boy. Where is my soy? I'm just restarting the boat. Okay. Hopefully that did the thing. And okay, open SSL. Yeah, here's the gist. I want to open it. Because I keep forgetting the structure of HTTP and stuff like that. So let me see. So it's usually get and then resource and HTTP 1.0. I don't know why I put 1.0 in there, but I mean, it's all right. In our case, it's going to be 1.1, I suppose. Right, so that means I have to provide methods and resource together. I have to provide them together. And so the next thing, we also provide the host. Well, the host could be provided by the headers. So the next thing I suppose we need to provide is request header, right? So we have to provide the request header. So I think these things should be called request begin and request end, right? So in here we're gonna have HTTP. I'm HTTP, and we're gonna have header name and header value. So I remember that I said that I wanted to have like a printf interface for header, but again, it's kind of outside of the scope of what I'm trying to do right now. I'm trying to implement like a minimal thing. Okay, so we're implementing like a minimal thing that works. So here's the request header, and then we're gonna do HTTP body start. I wonder if it has to be like a body start or headers, maybe request headers end. I think it's going to be a little bit better. So essentially you list the headers, and then you end them, and this is where you may or may not start the body. Makes sense, right? May or may not start the body. So in here, we're gonna accept this entire thing. It's gonna be HTTP. And after that, we need some sort of a function that does what? Request body chunk. Right, and here we're gonna have something like this. And maybe it's gonna be chunk sister, right? So basically you can just pass null terminated string and it will just send it as a single chunk to the server, or we usually want to have two versions which also accept like chunk sized, right? It's when we don't have a null terminated version but we know the size of it, right? So we're gonna put it like this: I'm HTTP const char chunk, and then it's going to be size t chunk size. There we go. So these are basically the functions that we'll probably need right now to send a request, right? To send a request. Once we are able to send a request, we need to think what kind of interface we're going to have for response, right? So let's separate implementation, and if it's going to be something like this. There we go. So let's implement all these things in here. Let's implement all these things in here. So can I just use a little bit of Emacs magic to do that, all of that for me? Okay, so this is going to be that, and this is not what I want. Okay, and just something like, there we go. So here are all of the things. All right, so now can I try to use this library? So we're gonna have some sort of an example that tries to use this library. stdio, stdlib, right, stdlib, and include I'm httph, right? So again, I need to define I'm http implementation, right? I'm http implementation. So here it is. So it's going to be null terminated. And first we need to establish the connection, right? We need to establish the connection. So to establish the connection, maybe I can copy paste a lot of this code. So sounds like a good idea. So we're gonna do a plain HTTP for now. We're gonna do a plain HTTP for now. Okay, so then this is basically where we resolve the host, right? We resolve the host. All right. Yes, you won't need to do that when the library is finished. The only reason why we have to do all of that by our hands is because we just started to... I really apologize. It's like, yeah, it's fucking... The PTSD is fucking real. Okay. So here I'm resolving this entire shit, and yep, we're not gonna establish an OpenSSL right now. We're not gonna establish it right now. So yeah. Okay. So I wonder if I can now assign SD to the socket. So this basically resolves a particular host. We don't really have a host in here, so let's actually define host. It's going to be something like host.sodin.org. All right, and yeah, so there is also port for some reason. Well, in our case, the port is going to be 80, right, because it's HTTP, plain HTTP, not HTTPS. So it's going to be socket. So if I just assign SD as a socket, I think it's not going to compile because it's like a type mismatch. So yeah, let's try to recompile this entire thing. Oh, we don't even have a makefile. Let's create a makefile for this thing. So it's going to be main.c, I'm http.h, I'm http.h, and it's gcc o main c. Do we need anything else? Maybe I just want to do it like this. Also, I want to actually customize C and C flags. Right, so C flags is going to be WAll, right? WAll, W extra. The standard is going to be C11. The thing is going to be pedantic. Right, the thing is going to be very pedantic. Let's try to do make in here, and it does not compile because, well, we have a lot of warnings about unused variables, and I don't like to disable those warnings because they quite often help me to catch pretty nasty bugs. So what I'm going to do in here, I'm going to just, you know, ignore all of the arguments in here until they're needed. So it's going to be something like that. So void I'm http and header name, header value. It's going to be void I'm http, void I'm http, chunk sister, void I'm http, chunk. This is a regular chunk and it's a chunk size. Void I'm http. Alright, so we also have error null. Let's include error null. Right. Error null. And so we need a string in here. So we need a string. And of course, as I already said, well, it didn't really fail that much. Initialization void from int makes pointer from integer without a cast. Yeah, so essentially what we want to do, we want to explicitly say that we convert an integer to void star. Right, but the problem is that like the size of the integer in the void star is not the same, so we won't be able to just do something like write equal write and read equal read. It's not a thing you can easily do, and I think GCC is actually smart enough to never let us do that. Yeah, so request for member write in something not a structure or union. What a terrible error message, or what incompatible pointer. Oh, it's because I forgot the comma. Yeah, terrible error message. Okay, so caster pointer from different size. Exactly. Oh, well, no, not exactly, but yeah, here. Initialization of these different things, but it still kind of allows you to do this kind of stuff, even though it just spits out the warnings. Okay, so, but again, if they're different size, so the functions are not compatible, right? So it may corrupt the stack, right? I think. So if you take a look at size of, and I have a 64-bit architecture. I mean, who doesn't? I mean, it's 2021. Right. So, well, I mean, on the PC or whatever. So in here we're gonna have what? It can be ZU, a size of integer equal ZU, and it's a size of integer. And this one is going to be void star. And let's see what they're going to print. And if I just run those things, and yeah, there you go. They're different size. You can just easily do that. So we'll have to adapt all of that stuff. We will have to adapt all of that stuff. So maybe we can just quickly write a wrapper. Right, I'm HTTP. No, this is not what I need to do. So I'm gonna go to I'm HTTP, and I'm gonna accept HTTP socket. So it's gonna be socket const void buff size t count. So in here I also return as size t. Right, and in here I'm gonna return write socket to integer, right, buffer count. There we go, buffer count. So in here we're gonna do a read, right? So this is gonna be a read, and this one is essentially read. And there we go. So in here we can just do something like HTTP write read. And so cast from pointer to integer of a different size. Yes, I know that. Okay, so maybe I can do something like, all right, I know that it's int64, right? Can I cast it to int64 and then cast it to integer, basically truncating it or something? I think it's okay with that. Right. So basically I'm telling the compiler, yes, I know they're different size. So yeah. I know that they are different size. Okay. So, and this cast to the point from integer different size. Oh shit. Well, I mean, maybe we can do something like int64t yet again, and okay, interesting. We just had a very interesting conversation with the compiler. Yeah, we just had a very interesting conversation. All right. So then I'm HTTP begin, and so what we're gonna do in terms of a request. So it's gonna be a request begin. I'm HTTP. I'm gonna provide the thing in here. I'm HTTP get, and what kind of resource we're gonna get in there? Let's actually get slash index HTML. Why not? Let's just get a slash index HTML. And after that, we have to end the request. Right, we're ending the request. And yep. All right, so what kind of headers are we going to put in there? So we can put a header host, at least, HTTP, something like host. And right, we're going to have a host in here. And do we need anything else for now? I don't think we need anything else. So rec headers end, right? We end the headers. And I guess like in this specific scenario, it is it, right? We don't have to, yeah, we don't have to do anything else in here. Just to query sodium.org, but it would be nice to actually test some other things. To be fair, we could try to actually query something like localhost at 6969, and at 6969 we could put netcat or something, right? So it could be something like this, and just to see what it sends in there. Right, and then if I do curl HTTP localhost 6969, we can clearly see what it sends in there. So maybe that's one of the things we can do. It's not a bad idea. But Zozin, have you heard about HTTP pin? Okay, so yeah, what we can do in here, I can actually put like a couple of bullshit ports in here. So it's gonna be foo bar. Not bullshit ports, bullshit headers. Hello world, and then in case of a body chunk, right? Request body chunk. We can put something like this. It's gonna be I'm HTTP hello world, right? Then maybe I'm gonna put like a new line in here, and then it's gonna be something like test. There we go. And because of that, yeah, okay, so already updated everything. All right, none of that is gonna work right now. All right, none of that is gonna work, and once this entire thing compiles, we're gonna go ahead and try to implement all of these things there. Right, so yeah, connection refused. Nice, could not connect to localhost 6969, connection refused. That makes sense though. Right. So if I try to do NCL 6969, all right, and I'm gonna try to reconnect again, yeah, it actually just closed the connection. It opened the connection and it just closed it immediately. Okay, so maybe we have to close it in here, something like that. That will make sense. Probably that connection is refused. All right. Cool. So let me sip my tea. So request begin. How do we begin the request? How do we begin the request? So we have to first print the method. Right, so we need to be able to convert method to a string. All right, so let's have a function, an internal one, that accepts a method and returns it as string. So http method. All right, I'm gonna switch like that, and the things we have in here, right, are only get and post. Right now we only have a get and post. So let's put these things in here. This is going to be a break, this is going to be another break, and in case of a default, right, we're going to assert 0 and http method unreachable. There we go. So to be fair, in these cases we could just return these things. There we go. It reformats it anyway. Okay, so now what I need to send? I need to send a C-star. It would be nice to have a function, something like http write C-star, and it accepts http context, right, and the C-star that you want to write. So interestingly enough, we don't handle any errors right now at all, especially when you write something or read something. I think we should handle them somehow, but I'm not sure how exactly we have to handle them. So yeah, first of all, we need to know the size of the C-star, so it's going to be the size. We're going to use strlen, and then we're going to call to the write function. The write function accepts the socket, right? It accepts the socket, then the buffer, which is going to be the C-star, then the buffer size. There we go. And this write function usually returns how many things it wrote. So I don't really know what to do in this particular case. Maybe for now, I don't know, to do does not handle http write errors, right? So we're gonna put it to do in here. We're gonna just ignore all the errors for now. Okay, so what we want to write in here is essentially method, resource, and the version of HTTP, right? So it's going to be something like this. I'm HTTP write C-star, I'm HTTP, then I'm HTTP method as C-star. It would be also kind of cool to have like a printf format there, but I don't think we'll be able to do that. Well, I mean, we can implement our own printfing or something like that, but I think it's too much to ask. So it's going to be method, and then we'll have to separate this entire stuff with a space, right? So because after the method comes the space, right? After that, what we're going to be doing is we're going to be putting the resource in there. So this is going to be a resource. Do we need to check for the malformed resource in here, or is it up to the user? I guess, I don't know. So I might put it to do in here. So it is easy to make the resource malformed in this specific function, right? So I'm going to just put it to do in here, and let's just continue working this entire stuff. So we have a resource, and then we have a empty, we have a space yet again, and maybe after that I want to put something like HTTP 1.1. Maybe for now we're gonna do 1.0. Okay, let's actually put 1.0 for now, and then we may upgrade it later in the future. Okay, there we go. So that's basically it. We started the request. I think. Let me try to compile this entire thing. So is it gonna work? Is it gonna work now? Let me include assert. So I'm including the assert. All right. Okay. So next we need to send the headers. Right. We need to send the headers. So the headers kind of like have a similar situation, like it's easy to put garbage in there, and the question is it up to the user to provide correct things or up to us to fix that? I don't know. So write sister I'm HTTP, and it's going to be header name. Right, it's going to be header name, then I'm HTTP, write sister I'm HTTP, something like this, and this is going to be header value. Then we go header value, and then we're going to do /r/n. There we go. So we have a header now. So we have a header now. So headers end, well, headers end is actually pretty straightforward. It's just HTTP write sister, and in here it's going to be simply /r/n, and that is it. In case of a body chunk, it's also pretty straightforward. It's just HTTP write sister. It's literally that, believe it or not. You just, you know, write this thing. In case of a sized chunk, you essentially call to the original function because it accepts this size. Right, like this. So we accept this token, this is going to be the chunk, and this is going to be the chunk size. There we go. And yeah, we implemented everything. So, and I don't know how to end it here. So, but it's nice to have end just in case we'll need to do special logic in there. So I'm going to just keep it for now. All right, so, okay, everything seems to be compiling. Let's try to run it and see if it actually sends anything reasonable to this specific port. And this is what we got. We got get host localhost foo hello world, and then this is the body. And okay, that's nice, but is it like actually correct thingy? So let me see. I would like to use something like HTTP bin, to be fair. It would be kind of cool to use HTTP bin, but I'm afraid that I'm gonna leak a lot of like information in there. So let me see, because HTTP bin like straight up shows you IP. You can, okay, you can run it locally in a Docker or something. So basically the official website suggests you can just run this thing like that and it's gonna work. Is it gonna work for me? Got permission denied while trying to connect to Docker daemon socket. I don't remember. Do I have to do something with the Docker special? Probably. Is it because I'm not in a Docker group? Oh shit. That's very interesting. What if I actually... I think my other account on this machine is in a Docker group. Yeah, it is. Yeah. Wait. One more time. I think I saw it somewhere. Yeah, here it is. Here it is. So if I try to run it under a different account, will that work for me? So I'm gonna just keep it on the second screen and maybe it will do things. Oh boy, oh boy, oh boy. Where is my... So it's doing things. Hopefully it's not going to take too much space on my hard drive, because I don't really have that much space. I only have a 10 gigs. I have a pretty old laptop. Please be gentle with my laptop, Docker-sama. Okay. All right, starting... Okay. Did it start? It feels like it started. So if I do, let me do that on a separate screen, because I'm really afraid that I'm gonna leak something. Oh shit! Oh fuck! Nice. It actually works, believe it or not. It's locally, it's localhost. Wow. A Docker technology. Isn't Docker great, Zozin? Isn't Docker great? I think it's great, Zozin. So let me curl that thing and just see what's gonna happen. Is it gonna leak shit ton of my information or something? So it's gonna be just HTTP, and I'm gonna. Okay, and how do I use it? HTTP methods. Okay, so I just have to do get. Right. Well, it kind of does. Oh, it's so annoying. But it's actually leaking my IP in my local network. So, but it's like I still don't want to show that because reasons. Because reasons. What an annoying piece of software. My God. My God. How can I not do that? Like, if I try to actually curl 127.0.0.1, it still shows the origin. Like, why do you do that? Why? Why? Can you just... I think I just have to listen it to locally. But the question is, how can I make it listen it to locally? I just don't know. HTTP was always annoying, like when I try to use it on a stream, it's just like, by default, it's just like, yeah, I'm just gonna show you everything. Just whatever, it's just like, yeah. So is there a way to customize that? Like customize what it listens to? Oh, so there's something in Docker Hub. I just wanted to show the origin as 127.0.0.1. It's just like the only thing I want, but it just doesn't want to do that because it listens to 0.0.0.80. It's just like yikes. So maybe I can Google that somehow. HTTP bin. Maybe I'm wasting too much time on that. Okay, so again, I'm not gonna waste that the time on the stream anymore. I'm sorry. It's a very annoying piece of software, and I'm streaming right now, so I better focus on something that actually gets me closer to the finished thing. Okay. What an annoying piece of software. Like, I swear to God, it's definitely not for streaming. But I mean, it's like, it was not designed with the streaming in mind, of course. A lot of software, by the way, these days is not designed with streaming in mind, right? So it's just like, it's only Discord that has the streaming mode. But apart from that, like everything else is just like doesn't have a stream. I wonder if in the future, like it's gonna be like a selling point of the products. Yeah, we have like a streaming mode. So because streaming and using a particular piece of software gives some sort of a promotion. So depends on the streamer. I don't know. Maybe not. It's just like different thoughts that I have that nobody asked for. Anyways. I'm pretty sure there is some flag in HTTP bin that you can set and make it listen only to 127.0.0.1. You can find it in that documentation, but it was not obvious. And I'm in the middle of streaming, and I'm in the middle of explaining things and creating the content. So I decided to put it away on the back burner. Later, when I have time, I'll look into that. Don't get wind up because of me not knowing how to use every piece of software on planet Earth. Okay, so let's just continue. It is what it is, and it isn't what it is. So we managed to make a request, right? That's one of the things we managed to do. It would be kind of cool to be able to now to handle the response. Handling the response is actually a separate thing on its own. Right, because we can only like read by a fixed chunk of data. So we'll have to sort of append that data. To be fair, the usual status bar and headers is relatively small, so we can pre-allocate a relatively big buffer which will hold all of them. And if status plus headers don't fit into that buffer, that means there's something wrong, so let's not even handle that request in the first place. You see what I'm talking about? Right, in that case we can just say, yeah, there's something fishy with this request, like just like, yeah, because I'm pretty sure the combination of status bar and all of the headers shouldn't be that big, right? It should be relatively small. And since well, I mean, how big can it become? Is it gonna be 1 gigabyte? Probably not. And if you have like a status plus headers of 1 gigabyte, maybe you're doing something wrong. But I mean, people parse 10 megabyte JSON file with scanf. So maybe I'm gonna make a small break before I continue. All right. So shit. Yeah, 3 minutes. Do you guys want to listen to some music? All right, sounds all right. Let's make some work. You guys have fun. Sorry that I'm a little bit late. I put some tea and oh, okay, so it is working. Oh boy. I'm just waiting for my kettle. Yeah. So for the response, right? So maybe we're gonna have some sort of a buffer for the response. Which is gonna be inside of IMHTTP. It's gonna be fixed buffer. Let's put it this way. Response. How would you call a combination of status and headers? Maybe there is a specific name for it, but it's probably described in RFC, but I'm too lazy to look into RFC. So I know that there's a status, not status bar, but status line. I'm sorry, I mispronounced it. I misnamed. So there is a status line and the header, but combination of them. Okay. So I'm gonna quickly go to the kitchen, pour myself a cup of water, and I'm gonna be back, and we're gonna continue. I wanna at least be able to parse the responses, at least for now. Yeah. French press broke. It makes me sad. Makes me truly sad. It was good French press. Also, for parsing headers, using string views is actually a pretty good idea. It usually works really well. Maybe it's a response metadata. So let me see. So there's HTTP hypertext transfer protocol. So here's the responses. Nice English, by the way. Nice English. Okay, so my window is too small. Is there an example? Thank you. So server response. So this is a status line, this is headers, and this is the body. And they don't really give you the name of the combination of the status bar and headers. So I guess we'll have to come up with our own name for these kind of things. And our own name is going to be response meta. Right, let's call it response meta. And IMHTTP response meta capacity. So it's going to be a particular fixed capacity. And how big this meta can become, like seriously. Is 640 kilobytes enough for everyone to parse the meta or not? I don't know. Maybe it is, maybe it isn't. Who knows? So we're gonna allocate how much, like even if you take a look at the size of this thing, right? So, which is actually pretty small metadata, it can become pretty, like relatively big. So it's around 250, yeah, it can fit into the Pascal string. As far as I know, Pascal strings are 256 characters, right? This one is 251, so we can fit that even in a Pascal string. So maybe 1 kilobyte for now. Let's actually put it as a 1 kilobyte. Right, oh, it's supposed to be called kibibyte. I'm really sorry. It's supposed to be called kibibyte. And if it's not enough while we're developing, while we're developing we discover that it's not enough, we can always increase it, right? So there's no reason to worry about meta capacity being too small for real world. So I'm pretty sure there should be a fixed buffer for response meta. Like seriously, how big do you want to make your response meta? Like seriously, like 1 gigabyte, 2 gigabytes, 1 terabyte, right? This kind of things should be small, and if it's too big, like we're definitely doing something wrong. We're definitely doing something wrong as human species. Maybe. I don't know. And yeah, having like a fixed buffer for this thing actually simplifies a lot of things. So you have a response meta, and then we can have something like response meta size, right? So how much we actually put into that buffer, and once we have that, we can try to parse it. Right? We can try to parse it. Another interesting thing is that we can try to read the whole capacity of the thing, and of course it can start reading over the metadata. So it may read the whole metadata, and then it may start reading the body. So we need a way, after we read the whole response metadata, to actually separate the metadata from the body. And the body, we can create like a separate buffer in here, response body chunk. And what's going to be that response body chunk? That's a good question. I suppose we can have something like I'm HTTP response body capacity. Body chunk capacity, it has to be actually body chunk, it's not the whole body. Right, and it's going to be around, I don't know, so it could be around 1 kilobyte. So interestingly enough, if the body will get into the response meta buffer, right, we should take that chunk of body after the metadata and sort of copy it into the body chunk in here, right, into the body chunk. And that chunk should always fit into this capacity, and if we make capacity of meta and body chunk the same, it will always fit in there. So I guess that's totally right. Okay, so here is the response body chunk size, basically how much stuff we have in here, and essentially you read the whole body by reading these chunks. So this has nothing to do with the chunked encoding yet, because we don't support chunk encoding yet. So this is needed just to read the stuff, just to make it work. And then we can think about chunked encoding and stuff like that. All right, so, and the first thing we want to do, right? The first thing we want to do when we handle the response, I guess we need special functions in here. So it's going to be I'm HTTP response begin, I'm HTTP, and we need to do anything here? I suppose not. Let's just create two sort of functions, begin response and end response, and we'll see what's going to happen. Right, so this one is going to be this, it's going to be void I'm HTTP. Then it's going to be void I'm HTTP, and there we go. So we start the request, and we end the request. After that, I'm HTTP response begin, HTTP, and then we're gonna do some things in there, probably just iterating through the headers, parsing headers, and so on and so forth. And then we're gonna do HTTP, I'm HTTP response end. So it's gonna be I'm HTTP. Okay. So it's gonna be something like this. All right. And so what we do in res begin. In res begin, we need to read the whole metadata, whole response metadata. I think I put too much salt in my tea. Oh well. So let me go somewhere here. So response metadata. So I need to read, I need to call read I'm HTTP, read I'm HTTP socket, right? So here is a socket. Then we use I'm HTTP buffer, response meta, and then how much do we want to read? How much do we want to read? We want to read precisely this amount, and this entire thing also returns you how much we read, right? So how much we read. But it can also fail if it's negative, right? If it can also fail that it's negative. So we're going to put assert and less than 0, and then we're going to say to do I'm HTTP res begin does not handle read errors, right? It doesn't handle read errors properly. We just assert them. And after that, I think what we need to do, right, here's an interesting thing. So imagine that you have this response rather. Right, so here's the response. So your size of the metadata, right, size of the metadata is actually big enough you can fit the entire response in here, right? So you read the entire thing and you actually read everything into the metadata. So now what we need to do, we need to find the line that contains only /r/n and take everything after that line that we managed to read and move it to a different buffer, to the response body chunk, and limit the amount of limit the size of the response meta size to just containing this, right? That's essentially what we need to do. We need to read it, but when we read it, we may accidentally overshoot it because the meta buffer is actually quite big. So we need to like sort of amortize it back. So we read, we overshoot, and we bring it back, sort of normalize it, or I don't know how to call that process, but that's essentially what we need to do. And this is precisely why we have /r/n, so we can find the place where this thing is like ends. And essentially, if the, again, we need to have a meta buffer big enough so it can always fit this metadata. And if this metadata is super big and we can never come up with the size of the buffer that ever fits anything in here, I think we're doing something wrong, and maybe the web is doing something wrong. I don't think this kind of thing should be too big, right? If you require to actually send too much metadata over HTTP protocol, maybe it makes sense to put it into the body. All right, make it sense to put it into the body in some, like in the form of JSON or something, because reading the body, it like actually requires a completely different approach, because body can be quite huge, and that's why we have chunks and with stuff like that, right? So in my opinion, like this metadata with headers shouldn't be too big, and it should always fit into a small buffer. And as far as I know, I think even like in case of a lot of HTTP servers, they have a limited size for this section, right? So they allocate like a limited buffer for this kind of stuff. Okay, is there something like if we try to Google that, I'm actually really curious. Does Nginx, for example, have a limited buffer for this thing? Nginx headers buffer. So reverse proxy. Well, probably kind of difficult to find something like that, but yeah. Oh, large client header buffers. What? Nginx large? It's a thing. It's large client header buffers. Sets the maximum number size. Oh my god, it shifted. So the number size of buffers used for reading large client request headers. A request line cannot exceed a size of one buffer or errors returns to the client. A request header cannot exceed the size of one buffer as well. Buffers are allocated only on demand by default. The buffer size is equal to 8 kilobytes if after the end of the request process in connection to addition into keep alive. Holy shit, okay, interesting. So it is a thing. So Nginx has a limited buffer, but you can always customize it. All right, so I see. And it's kind of interesting that they're yeah, they also have like the number of these buffers. Like they have like several chunks. Huh. That's very interesting. Okay. Huh. That means I'm kind of thinking in the right direction. So maybe I'm gonna steal this like this number, this magic number from Nginx, and if somebody asks me why did you allocate this amount, I'm gonna say it's Nginx. Nginx created by smart people. Okay. Anyway, so is it okay to allocate 8 kilobytes on the stack? Maybe it is okay. I don't know. But I mean, always you can always do something like static. So it's going to be allocated globally, technically. It's going to be allocated globally. So, all right, looks good to me. Huh. Very, very interesting. And again, so yeah, if you overshoot, maybe we can actually do the following thing. Right. So for now, response body chunk is going to be equal to response meta capacity. And okay, Nginx actually calls it header buffers. Let's also call it header buffer. I think it's too long. But it's primarily long because we use prefix response. What if I just use prefix res? Right, prefix res, so res meta, res body. To be fair, I kind of like meta a little bit better. I don't know why. I don't know why, chat. I don't know why. All right, so let's try to compile this entire stuff. Okay. So this is going to be a res. So this is going to be res, and this one is going to be also a res. So we have some problems in here. Initial is not constant. What? Excuse me. This is because it's static. Okay, can I just allocate 16 kilobytes on the stack? Okay, apparently I can, and at least I didn't crash or anything, but it's still too much. So yeah, essentially, well, I mean, I think we can still make it static if we move this entire thing to here, right? I think we can still make it. Right, so let me try to compile this entire thing. All right, seems to be compiling, and okay. So first thing we want to do, right, we want to read the meta buffer, and we already did that. Now we need to find where that meta buffer ends, right? Where does it end? And it ends at the line /r/n. That's where it ends. So we need to iterate everything by lines, right? We need a string view. We need a string view implementation. Unfortunately, I don't have a well-defined repo where I keep my string view implementation for C. So maybe I can steal it from one of my existing repos. I think I can steal it from VM. Let's see if I can steal this kind of stuff from VM. So in a library, I have SV, and I think SV does not necessarily depend on things. So I think it might depend on Arena. It doesn't even depend on Arena. Okay, so I think it's self-contained. I think it's completely self-contained, so I can actually put it here for now. So let me copy it in here. And this does not necessarily make this entire thing header only. But yeah, I think I'm gonna fix the lost header onlyness a little bit later. So maybe in the future, I'm gonna look at what functions I use for the string view, and I remove everything that is not unused, and I'm gonna embed it back into IMHTTP header. But for now, I'm gonna just keep it like that. Or maybe I could make SV also header only, I don't know. So in here, we want to include SVH, right? So here is SVH, and what do we need to do? We need to start iterating by lines. So what do we need to do? We need to take string view, and here is some sort of like a iterator. I don't know how to call it. It's just like iterator. So we take the response buffer, right, sv.h is going to be data, and it's going to be IMHTTP response. It's actually res meta, so this is going to be the data, and the count is going to be IMHTTP res meta size. There we go. So we have a size and data, and now what am I doing? I'm going to be iterating while SV is not greater than 0, and I'm going to be chopping off line by line in here. So it's going to be SV chop, not chomp, but chop by delimiter, and the delimiter in this particular case is a new line, right? And when do we stop? Well, we stop when line is equal to /r, precisely. That means we found the end of the meta, right? We precisely found the end of the meta, and that means the end of the meta is going to be located at SV data, right? It's going to be located at SV data. Right, because if we take a look at this kind of stuff, so we have /r/n in here, right, and we're going to be putting this stuff in here, right, so it's going to be like that, right, and we're chopping everything by delimiter, so once we hit this thing, we're going to have this as the value, and this is the delimiter, it's going to be thrown away, and then the rest of the stuff. So it means the body will start exactly at SV data, which is kind of cool, All right. We'll need to copy that data into the body chunk, right? We'll need to copy it into the body chunk and update body chunk size and the meta size as well, right? Okay, looks good to me. Also, I want to actually so this may not work if the body chunk is smaller than meta, right? So we need to make sure that, like, let's put static assert in here, that meta capacity is actually less or equal than body chunk. So let's actually ensure. So this is a quite important property that we need to maintain. We need to maintain this kind of property. Okay. Right, I'm thinking I want to actually move this entire process of figuring out the end of the meta and bringing it back. I want to, like, bringing it to the body. I want to have a separate function for that, but I'm not sure how to call such function. So we're gonna have something like this, right? So it's gonna be something like, it's gonna be static, it's not gonna be visible to the user. So it's gonna be I'm HTTP res, and it doesn't really accept anything except the whole state of the library, right? Because it's just modifying the internal buffers in there. But what's gonna be the name? So because you read the metadata, it overshoots and reads the body, right? And when you want to spring, okay, so spring back meta. Is that a good name for this? Because that's precisely what it's doing, right? Again, so we just have a fixed size. We say read this size, and yeah, so I don't know. I have nothing much to say. So I think it's a good name, but I mean, it kind of like doesn't explain what exactly it's doing. But yeah. We can actually give it more like direct description. So find end of res meta and put the rest to body chunk. Okay, I don't think so. Let's call it spring backbit. Zozin, naming is hard. Ah, did you know that naming is hard? Yeah, Zozin, you didn't know that, and you finally discovered that the naming is hard. Oh. All right, so yeah, we're gonna put all of that in there. I just realized that I forgot to do the following thing. I'm HTTP res meta size. All right, and let's move all of that to the spring back function. Right, spring back function. So I'm HTTP res spring back meta. And it should be just it. Yeah, I think that's pretty much it. Just bring it back. So this SV could be called something like meta. Let's keep. I have no idea how to call this thing. All right. So if we found R, we have to start copying things around. Okay. So what we need to do in here, we need to mem copy. The destination is going to be I'm HTTP res body chunk. So this is a res body chunk. Then what's going to be the destination? It's going to be actually SV data, right? So that's what we're copying in here. Surprisingly, how much data we need to copy? We need to copy a SV count amount of data. Okay, so actually everything works out quite beautifully. Everything works out quite beautifully. So, and I'm HTTP res body chunk size is going to be equal to SV count. There we go. All right. So that's pretty cool. And we also need to update the size of the metadata now. We need to update the size of the metadata. I don't know, maybe we can do something like I'm HTTP res meta size, and we're gonna take SV data and subtract I'm HTTP res meta. Right, so basically we're going to use pointer arithmetic to figure out the size, because data points after the size, so it will give us the actual size in here. But we also make a very silly assumption that this thing is less than SV data, right? So which should be always true, but who knows what's going to be changed up there, and this may trigger. So when you make these kind of dangerous assumptions, it's always a good idea to just assert it, just in case. You never know what's going to happen. And after that, we actually finished everything. And the only reason why you may want to fall off, why you will fall off from this loop, is when the meta buffer, the headers buffer, as Nginx like to call it, is too small and doesn't feed the entire metadata. And as already mentioned in that case, probably doing something wrong, and maybe something has to be done, like increasing the buffer. Like in case of Nginx, they basically, yeah, they allow you to increase the size of the client buffers, which is already kind of worrying trend, right? So clients shouldn't send big headers. Like, why do you send so much data in a header if you need to send a lot of data? Just send it in a body. That's body what was created for. That's precisely why body was created, to send a lot of different data. Just like I'm trying not to think about it. It just makes me sad. Anyways, so we're gonna insert in here meta something like I'm HTTP res meta is probably res meta capacity is probably too small. Not probably, but 100%. It is too small. That's basically what's going on here. All right, so yeah, we spring it back, and so we do the first read, and we already have something in the body chunk. So we read metadata and the first sort of chunk. So I'm gonna assume that you can read the whole metadata in a single read, hopefully. But yeah, I don't know. Maybe you need to loop until you fill up the whole buffer. Right? Who knows? We'll see. We'll see. We'll see. We'll see. Well, yeah, you can always. In case of like something like slow loaders, you can send by one character. Yeah. Maybe here you actually have to read repeatedly. Yeah. But I mean, how do you read repeatedly? How do you know until to end? So I'll have to think about that. We'll see. We'll see. Okay, so somebody sent me a message. Just a second. All right. Okay, so it also wants the yeah. Well, I don't know much to say here. Meta buffer should be smaller. I don't want to explain anything. It's just like so what we can put here. I want to put some useful information in there. If we overshoot and read more and read a part of the body into metadata buffer, we want that tail to actually fit into the res body chunk. Okay, so that's precisely why we are doing it like that. That is precisely why we're doing it like that. Okay, so let me see. So I want to actually split this stuff like that. Okay, so undefined. Oh yeah, so now we have to actually build with sv.c, and it compiles surprisingly, actually surprisingly. So the thing I want to do now, I want to print the metadata that we receive and then the part of the body. Right, so let me see what we can do. So I can probably do something like f write. Maybe we can print f meta, right? So this is going to be the meta, and then this one is going to be part of the body. Maybe let's call it body chunk. This is going to be a body chunk. F right. All right. So this is going to be the pointer, and what we're going to do, mhttp response. It's actually res meta. The size, it's a size of a single element. It's going to be 1 because we're printing bytes, and we're printing res meta size amount of bytes, and we're going to print them to the std out. And after that, I might as well put the end new line at the end of the std out. Do we have something like fput c? Fput s, yeah, that's what I wanted. Yeah, that's what I want. So it's going to be fput s. This is going to be std out. Fput s, std out. There we go. And in here, I'm going to be doing something like res meta body chunk. All right. And let's see if that's going to actually do anything. So this is not a pointer, I keep forgetting. This is not a pointer. And token something. Oh yeah, it's supposed to return something, I just copy paste it like that. Okay, this is not a pointer, this is not a pointer, thank you very much, C. And okay, so it seems to be working. All right, what I want to do actually, I want to try to send a request to tsodin.org, right, and just see what it will respond with. Hopefully it's not gonna dox me too much. Please don't dox me. And all right, so this entire thing has failed because I'm an idiot. It's supposed to be bigger than 0, all right? So not the other way around. All right, would you look at that? So here's the meta, and as you can see, we read the meta correctly, right? We read the meta correctly, and here is the chunk of the body, and it's actually, oh, and there we go. Over here we have a case of actually redirection, right? So this is a redirection. And what does it redirect us to? It redirects us to HTTPS, which is a good thing. It's a very good thing that it redirects us to HTTPS from HTTP. But yeah. Age 9? What the fuck? Disgusting. Okay. All right, it seems to be working. So maybe we can do something like and iterate the headers somehow. That would be interesting. So how can we iterate the headers? The hell is going on? So can you hear that? I don't think you can hear that, but anyway. So I'm just thinking what's going to be the best way to iterate through the headers, right? Because I don't want to allocate like yet another structure for this entire stuff. Right, and put my headers in there. It's an immediate mode library, right? It's an immediate mode library. We don't want to like, yeah, we want to immediately like parse the data and stuff like that. So what I'm gonna be doing is probably keeping track of the metadata, right? Keeping track of the metadata. So maybe we're gonna have some sort of functions in here, right? So that return you a status, right? So what's gonna be the status? Maybe the version of the protocol and the status code, right? The version of the protocol and this. Okay. I should probably maybe hide the chat, but I think it kind of makes it a little bit funny when people still write something in the chat. I think it's kind of fun. So right now maybe we only care about the status code. So let's actually return something like this: IM HTTP res status code, right? And we accept I'm HTTP, I'm HTTP like this. All right, and that should give us the status code. All right, so how are we going to implement this entire stuff? How are we going to be implementing this entire stuff? I think we need to keep track of some sort of like cursor, right? Cursor in metadata, which is just a string view. So meta cursor, something like this. And when you start the response, right? When you start the response and after you spring back the meta, you want to basically set the response meta buffer as the string view to the meta cursor, right? So this is going to be our meta cursor. Meta cursor. All right. That's pretty cool. So now when I do a status code, I'm extracting a line, right? So this is going to be a status line. I'm HTTP meta cursor, right? And it's going to be sv chop by delimiter. And it's going to be just like a new line, right? And then this is where we're going to be chopping off different things and whatnot. So what's the response here usually? So this is the version. We can chop it off by space. All right, so we're going to do something like this. Sv chop by delimiter. We provide the status line. Here is the status line. And delimiter is the space. So here we're basically skipping the HTTP version. Maybe I'm gonna put it to do in here to do. The HTTP version is skipped in I'm res status code. I'm res status code. Okay, and after that we are taking code sv chop by delimiter status line space. And there we go. We have a code as string view, and we need to convert it to an integer. So if I go to sv.h, is there any way I can actually convert it to u64? Okay. So let me return sv to u64. We do have a way to do that. All right. We do have a way to do that, and maybe because of that, this thing has to be uint64. I don't know why, but it's just like it's sort of like a naturally happened, and the reason is because this function returns uint64, and I don't want to do anything about it. It's just, you know, the classical thing. So what it has to be string in the view, of course. So this one is not a pointer. Is that what you're trying to tell me? Or I forgot to pass it by a pointer. All right. Okay. So let's try to do the following thing. After you requested everything, you can check the status code. So it's going to be uint64 code. I'm HTTP res status code. I'm HTTP, and you can print that status code if you want to. Status code is going to be LLEU, and it's going to be code. Let me see what's going to happen. And the status code is 301. 301. Okay, the next thing we need to do, we need to iterate through the headers. So let's actually implement something like I'm HTTP response next header, and essentially how we're going to be doing all I'm HTTP string view header name. So we're going to be passing the name, returning the name through the arguments, and we're going to be returning the value through the arguments as well, right? So we sort of like read the entire metadata into a single buffer, and then we have an API that progressively parses the headers, right? So we do not pre-parse the headers for the users. So user has to ask to continue parsing them. Does it make any sense? It kind of does. I think it's an interesting approach, actually. So you start the response, you read the whole thing, and then you just first parse the status code, parse the next header, and so on and so forth. And you know what's cool here is that you can parse the status code, right? And based on the code, you can make a decision. Okay, I don't want to even handle that response from the server, so I can close the connection before even reading anything else. So it allows you like progressively handle this kind of stuff. You know what I mean? So yeah, I just looked at the status code and the headers, and I already have enough information to even like reject that response and not continue having a conversation with the server, or continue. It just depends on what exactly you're trying to do. So you see what I'm talking about? I think it's kind of an interesting approach, actually. I think it's kind of an interesting approach. And all right, so we're gonna have something like this, and this is the status code, and so in here, and Boolean essentially returns true or false depending on whether you still have something or you don't have anything. Right, okay, so let me try. We're gonna read the next line. So this is gonna be the line, SV chop by delimiter, I'm HTTP. So this is gonna be a new line. There we go, there we go. Yeah, so this is the line. And then I probably wanna split it by a name, right? So it's gonna be the name SV chop by delimiter, I'm HTTP. Chop by delimiter, the delimiter is going to be something like this, right? So it's usually split by semicolon. I already lost my response. That response was actually super convenient. Okay, I'm gonna use this one. So it's usually split by that. All right, so we split by colon. We split by colon, and here is the name, and so we have to split the line in here. So in the line now, should contain the following thing. It's gonna be SV trim line. Yeah, so that's basically how we do all that. All right, so we take the line, and if line SV equal SV slash R, that means actually not equal. Let's put it this way: if it's not equal, we do that stuff. Right, we do that stuff, and return true. Otherwise, we return false, indicating that we read all of them. Indicating that we read all of them. So this one has to be like a meta cursor. Right. Meta cursor, and it has to be passed by a pointer. Anything else we need to know in here? Oh, yeah. Oh, I see. So slash R. Where is the slash R? Okay, so it has to be something like this. Yeah. Okay, so LU. Long. Okay, LU. Really? All right. Okay. So now what we can do: a string view name value, right? And while I'm HTTP next header name value. And HTTP, so it's going to be pointers. We're going to be doing printf. Header name is going to be svfmt. Svarg name, and this one is going to be value, and this one is going to be value. There we go. And we can also probably do something like this. Let me see, and there we go. We managed to parse all of the headers as well. So we parsed the status code. Maybe it will make sense to actually do it like this. There we go. So here's the status code, here's the headers, and we parsed all of them, which is actually kind of cool, not gonna lie. So then, do we have something like content length? Right, so we have something like content length, and we can probably use that content length to By the way, the library itself, as you query all of the headers, the library itself may actually take a note of some of the headers, right? For example, if it encounters content length, it can change its state to remember that the whole length is that. And then we can basically use that to read the body. We can use that to read the body. That's actually pretty cool. It's actually pretty cool. All right, so how are we gonna even do that? That's the good question. How are we gonna even do that? So essentially, maybe we can do something like content length, and when you start the response, response begin, right? We also do something like I'm HTTP, content length is going to be equal to 0. So we just reset the content. So reset the content length. So in here we read metadata. Read response metadata. There we go. So we have these two things. When we start the response, we clean up content length, and as we read through the headers, right? And if the name sv equal to sv content length content length. So are headers case insensitive? Maybe case sensitive, because I don't remember and I don't really care about it right now. Okay, so content length, if it's equal to that. Oh, by the way, content length, I think, has to be set to -1. Yeah, it has to be set to -1 because who knows, maybe content length is actually equal to 0. Let's actually set it to -1 to indicate that no content length was provided. Right, and if something was provided, we can actually try to set it, I suppose. So it's going to be HTTP content length is going to be equal sv as u64. Is it called as u64? Oh my god, Emacs, what are you doing, Emacs? Sv HTTP, yeah, 2. Okay, it's 264. And we're going to be taking the value, right? So also to do content length overflow, right? So, and we're setting the content length. And now, once we've finished reading the headers, we may want to have some sort of function called maybe IMHTTP REST next body chunk, right? So we have next header, and then we're going to have next body chunk. All right. So it's going to be boolean IMHTTP response next body chunk, right? Next body chunk. IMHTTP. IMHTTP, and how are we going to be returning that? I think we could return the chunk via the via this thing. I think. And what's interesting is that if we overshoot the metadata, we already have something in a body chunk, right? So the first call may not even initiate the read because we already have something there. So we need some sort of an indication, right, that yeah, we already have something in metadata. You can just read it there. Okay, so and we can return this chunk from here, right? And Boolean indicates that we actually read everything. Boolean indicates that we read everything. So let's put it like this. This one is going to be false for now, and maybe I'm going to even assert this entire stuff to indicate that it's not implemented yet. It's going to be to do, not implemented. Okay, so what we're going to do in here, main.c, and here I might as well actually do something like this. Yep. And then while chunk, right? So we have a chunk. Let's put it this way. So this is a status code headers, and this one is going to be body. Yeah, that's it, pretty much. So I'm HTTP res next body chunk. I'm HTTP chunk, and what we're going to be doing here is printf svfmt svarg the chunk. Restart the chunk. There we go. There we go. So that's cool and all. That's cool. This is roughly how I imagine you could use the library if you want to. But we need to implement next body chunk. All right. So here is the name, and since it's a pointer, I have to do it a little bit more careful. Yep. And what do we have in here? Unused parameter, and then as you can see it failed. Okay, that's fine. All right, as already mentioned, we already have something in the body chunk technically, so that means we need some sort of an indication that you don't have to read first time. So let's actually call it something like first chunk, right? First chunk, and when you start the response, right? When you start the response, and when you spring back the metadata, you need to indicate that this is the first chunk. So if you go here, we're going to do I'm HTTP. First chunk is going to become true. Right? Once you spring it back, it becomes true. So that means here, if I'm HTTP first chunk, what do? We set the chunk to false, and then just return the whatever we have in a response chunk. So it's going to be string view. Emacs, what the fuck are you doing? String view count. I'm HTTP res body chunk size data. I'm HTTP res body res body chunk. There we go. So that's basically what we do, and also we can just return true in that case. Return true. There we go. So after that, I think we should fail because it's not fully implemented. There we go. Okay, that's actually pretty cool. What I'm thinking is that we can take into account the content length. All right. I have an interesting idea. So I'm going to put an assert in here. And HTTP content length has to be greater or equal than 0. I'm HTTP can't handle the responses that do not set content length. So we're gonna do something like this. So it's gonna be a separate to do. Right, and as we encounter this thing, and we know for sure that content length is not negative, so it was already set, we're going to do the following thing. If I'm HTTP content length is equal to 0, we know for sure it's not negative. Maybe we can do something like this. If it's greater than 0, we do our usual thing in here. We do our usual thing like this. Otherwise we return false. Right? Otherwise we return false. So that means we exceeded the content length. That's what we essentially did. And in here we can do something like HTTP content length, and we subtract something like this. Maybe we can assert here something like assert that the size in here is smaller or equal to the content length. So yeah, essentially I'm HTTP does not handle the situation when the server responded with more data than it claimed with content length. We need to take this kind of stuff into account as well, right? But for now we're gonna do an assert here just in case. All right, and then we're gonna be doing something like this: content minus chunk, right? So this is gonna be minus chunk. And after that we return true, right? After that we return true. Okay, so this is only the first chunk, right? This is only the first chunk. For the rest of the chunks, we need to read this stuff yet again, right? We need to read the next chunk. So to do that, we'll have to do, let me actually run this entire thing and see if it's gonna work or not. Oh, and we have a case when, when everything fits into the single buffer and the response is exactly content length. So yeah, we have an interesting situation here. So this is assigned, so this is a chunk size. I think chunk size perfectly fits into an integer, so I can actually put it like this. So all right, so we already managed to handle something. That's pretty cool. Even though the next body chunk is not fully implemented, right? It's not fully implemented. We still managed to do something in here. Okay, that is pretty pogue. Pretty poke, pretty poke. All right, already streaming for almost 3 hours. Holy shit, time flies by. Okay, so let's do the read. HTTP read. I'm HTTP le socket, and what's going to be the buffer? So we're going to assume that we handle the entire buffer, right? Another interesting, important thing is that document that the chunk is always invalidated after each call. There we go. So this is quite important, right? So it's quite important to keep in mind that this can be invalidated and stuff like that. All right. So okay, so we're reading something. So I'm HTTP res body chunk. This is a res body chunk, and then we're gonna have something res body chunk. Has to be something like I'm HTTP res body chunk capacity, right? And that thing may return as size tn, and we're gonna assert that this thing is greater or equal than 0, or actually greater than 0, because if it returns 0, it may also indicate an error. Right? Yeah. Okay, so and let's put it like that. so this thing does not handle read errors, right? That's true. And what's interesting is that after this, we can just pretty much do the same thing, right? We can copy paste this entire stuff. Aha. Which actually hints that maybe we can compress this entire logic. You know what I'm talking about? So essentially, if this is your first chunk, send first chunk to false. Otherwise, read the new chunk. And then do all of this chunk nonsense that you wanted to do. Oh, by the way, here it's actually relatively easy to do something like this. If the user didn't provide the chunk, don't set the chunk. But interestingly enough, it's kind of difficult to do that for the header in here. But maybe, okay, I'm gonna put it to do. Don't set name / value if the user set them to null in here, in this specific function. There we go. All right, so in case of that one, if it's the first one, we just set it to 0 and ignore everything else and just return this stuff as usual. If it's not the first chunk, we read that chunk, and then this thing becomes res body chunk size and it's equal to n. All right, and we just handle it as usual. But we don't handle the read errors, but it's not even that important at the end of the day. All right, so let me try to recompile this entire thing. So there's another interesting to do. I'm HTTP depends on a separate translation unit, which does which makes it no longer header only. Right, we need to do something about that. I guess that's it. I mean, there we go. We send a request and we receive the response. We parse the status code, headers, and the body. And yeah, there we go. Nothing much to say, actually. It would be kind of cool to actually parse something bigger. But we'll need to make like HTTPS request, but that will mean that we need to integrate with OpenSSL library and stuff like that. I'm not sure if I want to do it right now, but yeah. So maybe we can put it to do in here. Methods not all methods are supported. Not all of them are supported. So yeah, so far so good. So the general usage of this library is a little bit painful, but this is because we haven't abstracted away a lot of the stuff. So I need to think how abstract away mean like establishing the connection. So I need to think how we can abstract that away. And maybe because there's so much stuff, like moving stuff involved, maybe we cannot make it a header only library. Maybe it should be just a regular library. I don't know. I'll need to think. But so far this thing gives you a lot of control. You can just, you set the headers, you set the body chunks and stuff like that. All right. We didn't even create a repo. Okay, let's actually quickly create a repo. I'm gonna git ignore this entire thing. I'm gonna ignore main, right? And maybe we should create a readme. So we already have a readme. Immediate mode HTTP library. Quick start is gonna be console. Make -b, then run this entire thing. So I also have to mention that it's actually I'm HTTP immediate mode HTTP client library. So that's quite important. It's a client library, not a server one. Though I think server one could be also implemented in a similar fashion, but right now we just need on the client library, right? Because we want to use it for the bot. So yeah, let's see. It's really, really interesting. So maybe the idea of making everything header only is not particularly great. But yeah, it was kind of interesting to try it out. I think this one shouldn't be header only, that's for sure, because of the complexity of HTTP in general, right? Because of the complexity of it. So yeah, let's do a committee and just create this entire, create the repo and stuff like that. All right, so ready, set, go, and let me go to the GitHub. Let me go to the GitHub, and I didn't want to do that actually. I just wanted to create a new repository. I wanted to go to Tsoding and click this button. All right, so I'm HTTP, and it's going to be immediate mode HTTP library. This one is going to be super public, and I'm going to create the repository. Okay, so I'm going to just quickly add the remote origin. Yeah, let's use it as the default one, and I'm going to push that right into the repo, right? And of course, I'm going to give the link to the repo in the description as usual, right? So there we go. So I'm HTTP. So this is I'm HTTP. Can I have something like Markdown mode? So this is the chat bot. Just initialization library and stuff like that. Okay. All right. So that was an interesting journey. Yeah. Okay. So I'm still not sure if it's a good idea because, well, I personally don't mind to use this API. I kind of even like this API because it gives me a lot of control, but I can see why some people wouldn't want to use this library because quite often than not, what people want to do is just to make it like a quickly get a request and just take a response in the sort of in a Python request fashion, right? So Python has a request library. It's actually pretty simple and pretty cool library. I really recommend to use it if you do HTTP requests in Python. So they don't want to deal with nitty-gritties of the HTTP protocol, right? But for my case, I kind of want this level of control because the idea of my chatbot is that I want to first of all have minimal amount of dependencies, so such a lightweight library is going to be plus. And another thing is that I want to keep everything in a single thread. I want to maintain IRC connection, Discord connection, and also make different HTTP requests, and I want to be able to do that all from a single thread. Right. To do that, I need to be able to do that asynchronously, right? So I'll have to mark all of my sockets as non-blocking and just handle all of that asynchronously. And this level of control over HTTP and what exactly is happening is, I think, theoretically, at least in my head right now, this approach actually works really well with asynchronicity, because at any point of the HTTP request, you can actually stop and do something else. In a single thread, by the way, right? So because you are in the middle of HTTP request handling, and yeah, you can just stop and do something else, and that's precisely what you want to do when you do asynchronous single-threaded stuff. So maybe it's gonna work well, maybe not. I don't know. Again, it's an experiment. This library is definitely not for everybody, and I'm not making it for everybody. It's not general purpose. I don't mean to make it general purpose. It's just for my specific cases, and I'm also exploring different design ideas, right? Trying different things, throwing different stuff at the wall and seeing what sticks. That's basically what I'm doing. Anyway, today was an interesting stream for me. Thanks everyone who's still watching this stuff. I'm really sorry that it was very ranty today. This is, yeah, I don't know. I think I'm getting old. Don't listen to me. I'm stupid, old and stupid. Anyway, thanks everyone for watching. Check out description. I put some links in there for you, just for you. So I'll definitely check out the source code of this project. So maybe like try it on your machine, by the way. Try it on your machine. Tell me if it works or not. If you have any questions, you can leave them in the comments. Smash like, subscribe, and all that Zoomer jazz. And I guess I'm gonna go. I see you all tomorrow, by the way. So tomorrow is a Friday, yeah. So that means we're doing a random one-off topic. So I'm gonna pick a random topic and I'm gonna stream it for the whole stream. Right? It's gonna be a secret topic. Well, doesn't make much sense in YouTube settings, anyway. But yeah, I'm gonna just try something new, try something interesting. Maybe some algorithm, maybe some data structure, maybe some language. We'll see how it goes, and yeah. See you all next time. Love you.